All right, I am currently looking at slide 0, line 1. So I would expect if I hit Control C now that Command IX is equal to 0, 1. Okay? Command IX is the index. Okay, so I am looking at C list CMD. This is the 0, 1 I'm talking about. I have the cursor in the list on the left and then the cursor in the commands on the right. And I have this index. And the index is the number of, or it's the slide number and the line number for every line that has a colon in the front. So if I go into JPrez and I look for the lines that start with a colon in screenplay, and I look for, and I pipe that through the word count of the -L for the lines, 9 lines, 9 indices. So those are the 9 indices. So these 9 left-hand side, right-hand side pairs map to the coordinates in outline space of those macros. So in the very first place, if I'm on line 0, 1, which I am, and I say index, and I use I 0, 1, I get 0. So the way index, or the way capital I dot works is you say hello index of the E, and that should give you 1. Sorry, I'm talking about this down here. I'm confusing myself. Forget that. See, this would be a great place where I would want to undo what I just did. If I were making a video, I am making a video right now, but if I were making like a real presentation video and I made a mistake like this, how do you get back into this state? You can't backspace up here and delete all this stuff. So if I wanted to present this, if this were a real presentation, I would now have to go back and rewrite this whole screen and make sure that I did it right so that in the video I didn't suddenly have this stuff appearing out of nowhere. Right? You have to edit it to get your screen back into the exact state that it was. How do you do that? It's a mess. You have to remember what all those commands are. So that's what this application does. So this is why I make this thing. Okay, so I've made a mistake here. So what I really should have said was, okay, so C, right? So here's me manually getting back to that state. C, commands, not that it matters. Let me say index. And then, okay, so now the length of the index is 9, right? I've had to do all this. All right, so index I 0, 1 gives us the 0. And then I made a mistake and I started talking about lower dot instead of upper dot. So what we really want is we have a sorted thing. So let's say let's just do all the vowels. A, E, I, O, U. Or no, let's say we have the alphabet. So NB, find the alphabet, find positions of vowels, given a letter, which vowel precedes it in alphabet. Okay? So my alphabet is, alpha is going to be, so we have this alphabet, right? That's all the ASCII character set. That's the entire ASCII character set, 0 through 255. You can't see them, but they're all there. The length of A is 256, right? So 0 to 255. All right, but we want a index of A. So the index of A, let's just back up a little bit. Index of A. See, second feature I want. I'm in the middle of typing this, and I want to remember that I'm going to go back and put alpha is this. Okay? This is what I want. I want alpha is equal to something, but not this. I'm in the middle of building what I want alpha to be, but in the meantime, I want to preserve that. So I want to have, I'm going to make a new buffer over here, but I want a stack. All right? And I want to take this part and push it onto the stack, right? As I'm typing in my REPL, okay? So AIA. All right, so that's the index of the letter A in the ASCII character set. And so we can just remember that or whatever. So now, and then plus, we add that where there are 26 letters in the alphabet, so we get those, and then we say A dot with those indices is the alphabet. So now, at this point, I want to pop this off the stack. And see, I want a button that does that. So that's what I want in my REPL for J. So to be able to push those assignments. Otherwise, as I went along there, I could have put this on the side, but then I would be talking about this, and then every line would say alpha equals something, and that's not right. Now, why do I need that? Because if I put alpha there, it's empty, but also just because this is a nonsense sentence. This is not what alpha is. I just want to remove everything off to the left temporarily while I work on everything off to the right. And so that's what this stack would be for. Push and pop items from left side of J line here. Okay, this is our character set back here. That's our alphabet. All right, so now we can say alpha equals this, and we'll just go ahead and make it a global. So that's alpha. And now I've also got all this garbage here. So I would like to be able, so feature 3 I want is to be able to just wipe away all this garbage that was all scratch work and go back to the state where I was resuming where I had these little comments here. So I want this. So now like all of this needs to be here. So this should be like NB come back to this point. So features. These are like features I want for REPL in future. This is great. These little impromptu things, like this has led me to this, and I want it so bad now that I don't want to make videos like this where I'm presenting things until I have this tool. So it's future NB. All right, we're back here. So now we found the alphabet. Yes. So now we want to find the position of the vowel. So we say alpha index of A, E, I, O, U. And so now the question is, given a letter, which vowel precedes it in the alphabet? So if we have the letter B, then we put this, we need to swap the arguments there. So hang on. So alpha, E, O, U, and then these are my bins. And then we want to say in those bins, the index of, so we're going to get a number. B is character number 2, right? Or is character number 1. A is 0, B is 1. So once we have the 1, no, I think we want this, right? Nope. Yeah, yes. I dot always confuses me. I always get off by 1 errors here. So if the index of A is going to be 0 and the index of B of E of alpha I E is going to be 1 and alpha I is going to be 2. So that you're right. And O is going to be 3 and U is going to be 4. So then the question is now, what about B? So B is going to be 1. C is going to be 1. I think I can say A, B, C, D, E, F, G, right? Yeah. There we go. All right, so we can say alpha I alpha, and then we can say alpha, and we're going to do that, and we're going to pair it up with its counterpart, each item, and that's going to give us a long vertical list, which we can then transpose. And so there's the mapping. And so all of this is to say this is what I dot does, what capital I dot does. So now I want a stack that tells me, okay, why did I do all this? I was doing this because I was talking about the index, right? So the index in our system. And so 4 is a stack for where the heck I am in a narrative, especially after I'm done with an example and popping off the stack. So that's I call this stackwise. The UI for this is to be called stackwise. Yeah. And then the next thing would be the idea of stackwise refinement. So then stackwise refinement is you start with the final thing you want to say and perform stepwise refinement using this stack-based UI. So the way that would have worked is I would have shown all these things, and then I would be able to time travel, right? So I have a time traveling REPL. Now that's where I want to time travel, back to the point where I'm done with the example. So use time traveling. I don't want to use the C cleaner. It's so annoying. I gotta uninstall that thing. Traveling REPL to go back to that point. And so stackwise UI would have time traveling REPL. It would have a visual display of your stack, of your goal stack. This is more of a token stack, right? So a token REPL stack, or really J token stack. To go back to that point, so the J token stack is all about use a stack the way the J parser uses a stack. So it's pretty much going to be like basically a 2-line REPL, and so that way you would be able to make things as you go along. All right, so use time traveling REPL to go back to that point. Visual display of your goal stack. So then, but this other stack-based UI I'm talking. So there's two stacks on the screen at the time. One is the one in the REPL that you're messing with, and the other is a conceptual stack of the goals you're working on. So visual display of your goal stacks, either derived from the word you're defining. So either derived from the word you're defining, or you can manually enter tasks, enter goals. Give this example, write this function, this other function I need. And what's the other one? Go off on a tangent describing the UI you want to build in future videos. And then, so a token stack for where the heck I am in a narrative. That's part of the stack. So this is all part of stackwise UI, stackwise refinement, and then actual UI, stackwise UI. I'll just call it stackwise, right? Keep stack for where the heck, keep a stack for where the heck I am in the narrative. Stackwise. Integrals go off on a tangent. Okay, so popping off the stack, we're done talking about what I want to build. We're going back to talking about what we've done with this example. And so now we're going back to talking about the index here. Okay, so my problem is that when I run this, it's going to work fine. Oh, that's weird. I hit a key while I was typing. Yeah. So you can't stop the macro. I think that's in here, stop during playback. I canceled that, but no, that's very important. It's not a bug, it's a to-do. Important because it could take a long time while you're using JPrez. And also, you don't want other keys to fire during a macro, or it'll screw up. Because the editor interprets your keys while the macro is playing. All right, so that'll be the top of the backlog for next sprint. All right, see again, you're constantly pushing and popping things off a stack when you program. You find a bug, add that to my list here, right? You notice a bug and want to fix it. This is blocking you. You want to refactor something. All kinds of things like that. And then when it comes to refactoring, sometimes you're about to do something, you find yourself, you're about to make a change, and you realize that if you had done another change first, or sometimes you're in the middle of making a change and you realize that if you had done a different change first, the current change would be a whole lot easier. And so you've already made some changes, but it would be so nice to go back in time and change some other thing first. Maybe even go back all the way to the point where this thing was first invented and change the way it was written. So what you want then is the equivalent of git rebase. You want something like git rebase. Restart your current task from a different starting point, a better starting point. So push your work in progress onto a stack, go back in time, change or refactor something, or make it right from the start, go back to the present, or play out history to end of that timeline to the new present, and then restart your current task from the newly improved start point. Mid-task, you realize that the current task would be simpler if some other task had been done first. All right, I'm out of time, but I do want to wow, even with a detailed plan, I did not get through one bug in my hour. But that's okay. I got to explain exactly, I got to verbalize while it was happening, all the motivations that led me to this tool. I think that's fine. I don't want to keep making 2-hour videos to edit. I think this is fine. From now on, there's not a one-to-one correspondence between these daily morning shows and the actual episodes that I published to YouTube. Oh, Sapnacore123, hello. That's someone who is very special to me. Hi, Sapna. I was just explaining, I don't know if you saw it, I was just explaining why I'm building this thing. I had a zillion good examples. Yeah, but I wrote them down, so they'll be in the video. All right, yeah, no, it just struck me like all the trouble I'm having with episode 11 has to do with how nested and recursive the act of programming is, right? You're trying to do something, but you can't because there's a problem in your way, so you have to solve that problem. And having a stack on the screen as a visual part of the presentation, this goal stack idea, like I've been wanting to do this for a long time. But having that stack on the screen to be able to show what you're doing and why you're doing it, I've always wanted it for myself, but now that I'm making presentations, like to make it easier to follow and understand what's going on in the presentation and to give the viewer context makes so much sense. I'll show you what I'm talking about with this user interface. I made this years ago, this little diagram that I'm about to show you. We'll make one of these when we find it off screen. I got to log into like Google Docs or something. I think I call them stackers. Stackers, yeah. This was from, it says January 18th, 2011. All right, so stackers are a new kind of tool that cooperate with outliners. So what's an outliner? Outliners are great for planning and organizing. They're not so good as a task list because, yeah, so here's your goal. Like, here's what you're currently working on, but you've got all this, like, not garbage, but it has all your context there. And you can't just see the tasks, right? So you have your current sub-goal, current task, another task, next sub-goal. And it's not just showing you your work. In fact, I had to do that here. Like, when I made this, I wound up, like, I had this nice and, like, hierarchical, but for actually doing the work, you just want the thing at the top. So you want two views of that, which is why you put your bugs in a database so that you can organize it however you want. But even then, even in Jira, it's difficult to see the outline view. So you want the outline view, you want the queue view here, but then you also want, what I want is this view, which is the stack view. So it shows you your current task, your next task, another task. So like the current task would have the current sprint sub list here. So what's next on the list? Or even just what's there, but then the sub goals and so on, you'd be able to see just the slice of what you're working on right now. And it would work just like a stack trace in a debugger. You have your goal at the bottom, you add more stuff to the top. You can keep notes at the top if you want. These are just not part of the stack. They're just like it's an area for adding notes. This is whatever you're working on right now. This is like up here. But then as you go up, you keep adding stuff to the stack. Or it can grow upside down if you prefer to see it that way, whatever. But you could also collapse it. Here we have all these current sub goals, next task, another task, but you can also, hide some of the context. Just what's your main goal, what's the current sub goal, and then hide even the next tasks in that sub goal. So it's a way of looking at a tree in context as a stack, right? So you have an outline, which is a tree, then you're looking at the kind of the breadcrumbs, but you can also choose to see some of the branches that are adjacent to different parts of the tree. So like here, you're on a branch, here are adjacent branches, which are the things that you're doing next. But if you want to hide that, you can hide those subtasks. And here, these are the kind of the paths along the tree. You can just collapse that path and so on. So that's I think that's it. That's the whole presentation. That's the user interface that I want for visualizing a stack. Basically, it's a visual debugger for like a stack trace for your conversation, for your presentation, your narrative. So, popping that off the stack, I want this to be part of the REPL that I'm building. So for future presentations, I want to be able to produce that kind of thing. Anyway, so programming is a very nonlinear thing. And the more complicated the thing you want to present, the more you really need to design your history, like the history of it, so that you do as few of these jumps as possible, because people are not good at keeping the stack in their head. So maybe making it explicit on the screen will make videos like a longer presentation easier to follow, a more, like a real live coding presentation where you're actually, solving the problem in front of you. Like that's what episode 11 was. It's 4 hours. I uploaded it. It's called A Confusing Waste of Your Time, because it is completely garbage to follow because of this recursive nature of programming, where, as I said, you start to do something and you can't because it doesn't work, and now you have to go debug that. And so you wind up with this tree structure where you're trying to make a point, and there isn't a part in the video where you worked on this goal, right? So if you did this, right, there isn't a part of the video for this, right? This part of the video is spread out the way this outline is. So you've got, the video looks like this, right? So you're working on your goal, you're working on goal 2.1, you work on this, and now you have this whole side project that you have to start to handle some weird thing. And so you got 15 minutes of this. And it's all a detail that had this been done before, it would have taken like 1 minute, and you would have jumped from this task to this task, 2.11, this is actually 2.22. But that's not how the real world works. It's just not how the world works, because you can't go back in time, but you could in a presentation, right? So to make a presentation, you have to go through all this crazy detours and stuff, but then along the way, in your process of doing that, you can go wandering through the forest looking past this rock and looking behind that tree. But once you've done all your exploring, you go back and you blaze a trail. Blazing a trail is to leave a marker saying which way to go, so the next guy doesn't have to go behind, or you in the future don't have to go look under the rock and behind the tree and go see what's in that cave and all these things. You can say, okay, go this way to get where you want to go, and so you blaze the trail. And so the very first version of a narrative tool that I made was called Trailblazer, and it used like a hypertext system, and it was a clunky Python thing. And then I had another clunky Python thing that would allow you to do this kind of thing in Python, where instead of just defining a class all in one place, you could have the narrative, and you could say you could introduce parts of a class as you went along, and it would just dynamically stick them onto the class. So basically, it was a decorator that allowed you to just reopen the class and add a method to it as you went along. Not because that's good for anyone reading your code as a reference, but it's great for somebody who is trying to understand the narrative of how things got to be this way. Usually you have a system that starts out very simple, and over time you add things to it. But what you don't want is you don't want to start somebody out. You want to start your explanation with the simplest system you can find that is something like what you're doing, and then add things to it over time. As you do that, you will go down all these rabbit holes, and you will realize that it would have been nice to do all these things. And so in hindsight, you as an educated person, you educated by your own experience, will go back and blaze a trail for yourself that says, okay, in order to get to point C, I need to do all these weird things that look weird. All these things need to be there. And if these things are all lined up just right, then you can get through the trail and everything will go smoothly for you. But it's like, say you're playing a video game and you don't know what the puzzles are, but it's just like you go into the haunted house, you pick up the sandwich. This is the speed run. You pick up the sandwich, you open the umbrella, and then you stand over here for 2 seconds and you jump. And you have no idea why you're doing those things, but those are the steps you have to do to solve this puzzle. I'm just making up a game here, but like out of context, they make no sense. And so to a learner of your system, they would make no sense. So the learner never wants to do a speed run. You don't want to start with a speed run, even though that's the most efficient way to get there. You want to start with the learner wants to say, okay, I need to go get whatever the goal of the puzzle is. I need to go down to the basement and retrieve my uncle's briefcase, whatever, so that I can get his will and claim the estate for myself. But it's haunted, and I have to deal with all these traps that my other crazy uncle left for me or something. I don't know, whatever. The point is that you as the player want to experience the story, and that's very different. Playing the story well and not making a ton of mistakes and experiencing it as a story is completely different from the speed run where you go in and do things that make no sense but optimize things. And so you as the presenter, or the game creator in that case, but the presenter of the narrative, are left with that same kind of choice. Like, how do you present it so that it's easy to follow? That the story of developing the system is easy to follow, but and as efficient as possible without becoming nonsensical. You don't want to have to grab the sandwich and open the umbrella. Like those two things don't. There has to be a logical progression to the story, but without needless detail. For a reader's point of view. Later, if you want to golf the speedrun, you can do that, and then you can say, I'm going to do this, I'm going to do this, I'm going to do this, and then here it works. But a speedrun is not intuitive. A speedrun only makes sense with the benefit of hindsight. You want a guide that takes you through the process and lets you kind of experience, the viewer experience the process of building up the natural progression of ideas as they go along, but without getting bogged down in details. So you want to present like the relevant problems and the sensible problems, but try and arrange them in such a way that it's still got a sensible narrative. And that's the whole point. That's the style of presentation that I've been wanting to arrive at for a very long time. And this stack concept is, I think, meant to be a cognitive aid for that. But it occurred to me now that the thought was that I could have used it if I had this interface on not this interface, but this interface, the stack view on the screen as I was presenting. Then to go back and edit that video, basically at any point when the stack is here, if you see a scene where the stack is like this, and then down the line you see another scene where the stack is like this, that's continuity. And in between there on your video, you will see the stack go up and down because, you got off on a side tangent, so there's 10 more things on the stack. But you can cut all that out and just jump from this point to the next point where you're at the same state, except things will be different in the world. It's the same thing in a program. When you write a program, like a traditional procedural program, and you have like a procedure, and then you put a loop inside of it, and then under some conditions you have another loop inside of that loop, and you could do all that. And often if you had a program, for example, like a simple thing like comparing a string might be a long, complicated loop if you wrote it out inline. So if you inlined everything in your program, it would be very complicated. And basically, if you took a 5-line Python program, and for every time you called a function, you just put the definition of that function in there, like you can absolutely do that. That's the structured program theorem tells you can do that. You don't have to have functions. You don't have to have a stack, or you have to have the ability to make a stack. But your control flow, all you need are loops and if statements. You need a while loop and an if statement. That's it in your program, and you can do anything you want as long as you can make a stack and data or whatever. So you could inline the entire program, and it would look like a complete mess, but you would be able to see it. So in one sense, it would be easy to follow in the sense that at any point you can say, okay, I understand what this line is doing. I understand what this line is doing. But it's like a forest for the trees situation. You don't want to follow at that level of detail. You don't want to. You can do the same thing by taking your program and compiling it to assembly language. And anytime there's a jump to something or a jump back, you can just always inline it, right? This is how you prove the structured program theorem. But it's not good television. It's not good code. You want a nice level of abstraction, and you want to gloss over those details. You want to say, okay, I'm willing to start out with the idea of a string comparison existing in the world already, right? That's an axiom of the system. It's part of the landscape. It's in your toolbox from the start. You don't want to have to stop and create that the minute you need to compare a string, because it's not important. But in real programming, you have to do that. You're doing that all the time. Not a string comparison, but you always need something that you don't have, and you have to go build that thing. And that forces the narrative to have a stack, and to be, if you jump from minute to minute, you're at different levels of the stack. And that's why you wind up with a confusing waste of time. And to go back and untangle the narrative of that it's very difficult. It's very difficult to do that in retrospect. But I think having a tool on the screen that shows you in context how that works, either as a viewer, you would be able to see what's going on. Okay, look, I'm debugging, or I'm giving an example. So as you fast forward, you can do that. But also as an editor, you can say, okay, this was a long sidetrack. I'm debugging this whole time. Maybe I can just jump to the point where I knew what I'm talking about. Yeah, anyway, so it just made me realize that I just realized that having this it is the cause of my troubles, why it's taking me like days and days to edit that video. So this is all what I'm building. And it is now 9:21, and I guess I am clearly not going to solve this bug. So I don't know if that was entertaining, but thanks for watching. See you again next time.